25.5 million Americans have disabilities that limit their ability to travel. For these people, the lack of reliable, accessible, and effortless transportation makes daily trips to work, doctor's appointments, grocery stores, and family trips difficult, if not impossible. While autonomous vehicles hold great potential for expanding mobility, they currently lack many design features that would make them accessible and inclusive for people with disabilities. Specifically, AVs need new design solutions to ensure safety for users as they enter and exit the vehicles, limit the obstacles users face when maneuvering within vehicles, as well as provide users with independent control and remote supervision when needed. The Purdue EASI Rider team has responded to the Inclusive Design Challenge with a suite of solutions that incorporate universal design features to advance how AVs can accommodate travelers with physical and sensory disabilities, including persons using wheelchairs or those who are blind or visually impaired. These solutions assist disabled users in locating an autonomous vehicle, entering and exiting the vehicle, securing themselves and their equipment in various configurations within the vehicle, and allow users to interact with the vehicle using touchscreen and voice control during routine and emergency situations.
We focused on individuals with mobility or visual impairments, and that makes up about 60% of the travel limiting disability population, because they both have difficulty physically interacting with technologies, with devices and instruments.
Our contribution to the prototype is the ramp, the floor system, and the docking station. The floor system is in production, so that's already being manufactured and sold. The ramp itself, we use a stage gate process, so standard automotive suppliers, they use a process by which they go through exploratory design, manufacturing. Our products are actually design complete and going into process design, so we're designing the manufacturing process for them.
The Paravan Touch Panel and voice control is used to control all secondary vehicle functions and is used worldwide by persons with physical limitations who drive wheelchair-accessible vehicles.
It would be helpful to use autonomous vehicles, just probably more frequently, and avoiding the huge frustrations of just traveling. It could be.
It was really easy. My favorite part about it was being able to look at the screen and not have to try to crane my neck to turn around to make sure I'm not bumping into everything.
We were very fortunate to interact with a number of local and national disabled communities that enabled us to be able to solicit user feedback. So that was our first major data collection for which we actually got feedback from potential users. The second thing we did was actually brought our prototype to the Purdue University Road School Transportation Conference and Expo that happened in March of 2022. Where we were able to show our design prototype to hundreds of people.
This effort has also created educational and professional development opportunities for students.
Just an undergraduate researcher, I'm tasked with a lot of different things. He gives me a lot of different opportunities to explore, just interacting with the different users that could potentially be interacting with our vehicle just in the daily world.
The team ultimately hopes that an award through the IDC might lay the foundation for establishing a research center to advance research and industry collaborations centered on the future of inclusive design in transportation.
Numerous studies have shown that transportation is very stressful to people with disabilities. And so this is important to allow them to use this technology as efficiently as someone without a disability. We want everyone who would have access to future autonomous vehicles to be independent.